You want your agent to follow your project's conventions, fill out a PDF form, and write a file to disk. Quick question, do those three go in the same place? They do not, and stuffing all three into one giant instruction file is the single most common mistake people make when they first set up an agent. Always use our commit style is a standing rule. Here's how to fill a PDF form is a procedure you need only sometimes. Write this file is an action. 3 different needs, 3 different mechanisms, each with its own loading behavior and its own cost in context. Let's nail all 3. Layer 1, AGENTS.md. A README for agents, a plain markdown file at the root of your repository holding the agent-facing detail that would clutter your human README. Its defining property is that it's always on. It loads every single session, no matter the task. Build commands, project layout, code style, your do's and don'ts. And it's vendor neutral. It started at OpenAI, but it's now read by 20+ agents across 60,000 open source projects. Claude Code's Claude.md and Cursor's rules files are the same idea under a different file name. But here's the nuance that trips people up. An instructions file shapes behavior, it doesn't guarantee it. The docs are explicit. This is context, not enforced configuration. So if you need a hard block, never run git push force. That's not a sentence in a markdown file. That's a different layer entirely, a hook or a permission rule. Layer 2 skills, where agents.md is always on. A skill is conditionally activated, loaded only when it's relevant. A skill is a folder with a skill.md file, packaging instructions and optional scripts. Its front matter has exactly 2 required fields, a name and a description. And the single most important authoring rule is that the description must say both what the skill does and when to use it. Because at first, the description is the only thing the model sees. That's the crux. Skills are model-invoked. The model itself decides to load a skill by matching the task against that description. No human flips a switch. The mechanism that makes this cheap is progressive disclosure. 3 levels of loading, and this is the part worth really understanding. Level 1, just the name and description, around 100 tokens, always loaded so the model knows the skill exists. Level 2, the full skill.md body, loads only when the skill triggers. Level 3, bundled files and scripts, read or run only as needed, and a script's source code never enters context at all, only its output. So here's why won't 30 skills bloat my context is a misconception. 30 skills cost 30 tiny descriptions until one fires. The heavy bodies stay on the shelf until they're needed. Layer 3, tool calls, which the tools lesson covered. The model emits a name plus JSON arguments, your code runs it, the result comes back. The action layer, the hands. And MCP tools are the same primitive, just standardized so any client can discover and invoke tools from any server. MCP isn't a different thing from tool calling. It standardizes how external servers expose those calls. Now watch how the 3 compose because they're layers, not competitors, and each points down to the one below. Agents.md sets the standing rules and can say for this use the X skill. A skill supplies the just-in-time playbook and its body can orchestrate tools, call read file, then write file. Tools are the actions both ultimately drive. So the decision rule is about frequency and kind, not preference. A fact that must hold in every session goes in agents.md and keep it short, under about 200 lines because longer files reduce adherence. A repeatable, specialized procedure you need only sometimes becomes a skill. And anything where the agent must do something or fetch live data is a tool. Here's the clean way to remember the failure modes. If your instruction file is 3000 lines, you've stuffed skills into the always-on layer. If you keep pasting the same procedure into chat, that's a skill waiting to be written. And if the agent knows what to do but can't make the change, you're missing a tool